Falls take the lives of employees in all industries each year. The majority can be prevented by using fall protection and following safe work practices. Each year, more than 15% of occupational fatalities are from falls. In construction, the only fatality rate higher than falls is vehicle collisions. When working at heights, the height requirement for fall protection is different in each set of industry regulations. For example, general industry requires fall protection at heights at 4 feet or greater, maritime at 5 feet or greater, and construction at 6 feet or greater. In construction, fall protection is required whenever work is performed 6 feet or more above a lower level. This includes unprotected sides and edges, leading edges, hoist areas, holes, formwork, reinforcing steel, ramps, runways, and walkways, excavations, dangerous equipment, overhand bricklaying and related work, roofing on low slope roofs, steep roofs, precast concrete erection, and wall openings. Various types of fall protection systems can be used to protect workers from injuries or fatal incidents, like fall arrest systems, fall restraint systems, guardrail systems, and safety net systems. Fall restraint systems are not mentioned in 29 CFR 1926 subpart M, but are recognized by OSHA as an effective means of protection. Personal fall arrest systems, or PFAS, is a system used to safely stop or arrest a worker who is falling from a working level. Use of a personal fall arrest system must follow specific guidelines contained in 29 CFR 1926.502. Fall arrest systems must limit the maximum arresting force on a worker to 1,800 pounds when used with a body harness. Be rigged so a worker does not free fall more than 6 feet nor contact any lower level. Bring a worker to a complete stop and limit the maximum deceleration distance to 3.5 feet. Have sufficient strength to withstand twice the potential impact energy of a worker free falling a distance of 6 feet or the free fall distance permitted by the system, whichever is less. Be inspected prior to each use for wear, damage, and deterioration, and remove defective components from service. When working with fall arrest systems, it's important to remember the use of body belts for PFAS is prohibited. PFASs are for fall protection only. Do not use PFAS to hoist materials. There must be a prompt rescue after a fall, and always follow the manufacturer's instructions. A fall restraint system tethers a worker in a manner that will not allow a fall of any distance. OSHA suggests a fall restraint system must have the capacity to withstand at least 3,000 pounds or twice the maximum expected force that is needed to restrain the person from exposure to the fall hazard. The ABCs of fall protection are the 3 components of a personal fall arrest system. These components are known as the anchorage, body harness, and connecting device. The anchorage point is also known as the tie-off point. This is the point of attachment for the lanyard or the lifeline. The anchor must support 5,000 pounds of pressure, or at least twice the expected load. Some anchor points are permanently fixed to a structure and some are removed once the work is completed. The body harness is the combination of straps that distribute the force of the fall over the chest, thighs, waist, pelvis, and shoulders. Harnesses have buckles and adjustable straps for proper fitting. The connecting D-ring should be located right between the shoulder blades. The connecting devices link the body harness to the anchor point. Lanyards, retractable lifelines, and shock-absorbing lifelines are different types of connecting devices. Lanyards and vertical lifelines must have a minimum breaking strength of 5,000 pounds, and snap hooks must be self-locking. Before each use, the user must inspect all personal fall arrest components for deterioration, excessive wear, bent hooks and rings, and evidence of impact damage. Once a PFAS has been subject to an impact load during a fall, it must be removed from service. In construction, snap hooks and D-rings must have a minimum tensile strength of 5,000 pounds and be proof tested to a minimum tensile load of 3,600 pounds without cracking, breaking, or taking permanent deformation. Only locking type snap hooks can be used. Connectors must be inspected to ensure that they are drop forged, pressed, or formed steel or equivalent material. Connectors should have a corrosion-resistant finish, and surfaces and edges should be smooth. Unless the snap hook is a locking type and designed for the connections, snap hooks must not be engaged directly to webbing, rope, and wire rope, to each other, to a D-ring that has another snap hook attached, or to a horizontal lifeline. Unintentional disengagement is also known as rollout. A rollout occurs when the snap hook disengages from the anchor point. If the snap hook or carabiner is not properly attached, a situation could occur where the connecting element applies a force to the gate of the snap hook or carabiner. This force may cause the gate to open, allowing the snap hook or carabiner to disengage from the connecting point. Additional considerations when setting up a personal fall arrest system. Each worker must be attached to a separate lifeline. Consider total fall distance and ensure maximum free fall does not exceed 6 feet. The factors that affect the total fall distance include length of connecting means including lanyard length, use of carabiners and snap hooks, position and height of anchorage relative to work area, position of attachment and D-ring slide-on full body harness, deployment of shock absorber, movement in lifeline, and initial position of worker before free fall occurs. According to OSHA, the employer is responsible for calculating fall distances for personal fall arrest systems. Total fall distance is calculated by total length of shock-absorbing lanyard, the height of the person, and the location distance of the D-ring from the work surface or platform. D-ring above anchor. Free fall distance equals lanyard length plus distance from the D-ring to the anchor. D-ring below anchor. Free fall distance equals lanyard length plus the distance from the D-ring to the anchor. D-ring level with the anchor. Free fall distance equals lanyard length. Employers must have a fall rescue plan in place when workers are exposed to fall hazards. OSHA 1926-502 addresses the procedures, equipment, and personnel needed to ensure that a rescue proceeds quickly and efficiently when a fall occurs. A fall rescue plan ensures the safety and well-being of workers. When a fall occurs, every moment counts, and having a well-thought-out plan can mean the difference between life and death. A major hazard a worker can face after a fall is a condition called suspension trauma, also known as harness hang syndrome. Suspension trauma can cause the worker to lose consciousness within minutes and may lead to death. It occurs when an accumulation of blood in the legs reduces the amount of blood in the circulation. If properly equipped, a worker can deploy trauma relief straps, creating a loop that a worker steps into and presses against to stand up. Relief straps are typically packaged in 2 pouches that attach to each side of a harness. Guardrails are physical barriers that prevent workers from accidentally falling off elevated platforms, roofs, or edges. They consist of a top rail, a mid rail, and a toe board, and can be made of various materials such as wood, metal, or plastic. If the employer chooses to use a guardrail system, they must comply with the OSHA provisions. Top rails must be between 39 and 45 inches above the walking working surface, able to withstand 200 pounds of force, and at least a 1/4 inch in diameter or thickness. Mid-rails must be installed midway between the top rail and the walking working surface, be at least a 1/4 inch in diameter or thickness, be able to withstand a force of 150 pounds, and may also be screen, mesh, vertical members, or solid panels. Guardrails for fall protection can be made of a variety of materials. For example, wood is a common material for job-built guardrails. Steel is a popular choice for its strength and durability, while aluminum is lightweight and corrosion resistant. Metal pipe can also be used. Wire rope can be used for top rails and mid rails. Guardrails can also be made of composite materials, which is a combination of materials like plastic fibers and wood particles. Toe boards shall be provided when employees below could be exposed to falling objects such as tools. Although some of OSHA's walking working surface regulations require toe boards as part of a guardrail, they are not mandatory with every guardrail. Toe boards should be at least 3.5 inches high and able to withstand a force of 50 pounds. Safety nets are used to protect workers from falls and falling debris. They're also used when it's impractical to use ladders, scaffolds, catch platforms, temporary floors, safety lines, or safety belts. OSHA states that safety nets shall be provided when workplaces are more than 25 feet above the ground or water surfaces, or other surfaces where the use of ladders, scaffolds, catch platforms, temporary floors, safety lines, or safety belts is impractical. OSHA CFR 1926.105 states, nets must extend 8 feet beyond the edge of the work surface where employees are exposed and shall be installed as close under the work surface as practical, but in no case more than 25 feet below such a work surface. Safety nets must be inspected at least once per week and after any incident that could affect the structural integrity of the net. Any objects that fall onto the net must be removed as soon as possible and always before the next work shift. Floor holes are commonly seen on construction sites. They can be found inside of buildings or on top of roofs and throughout construction job sites. A floor hole can present a trip or fall hazard to workers and can lead to serious injuries or fatalities. To avoid falling through floor holes, we must apply covers. Covers must be able to support twice the weight of any employees, vehicles, equipment, or materials that may be imposed on the cover. Covers must be secured to prevent accidental movement. Covers must be color-coded or marked with the word hole or cover. Workers should always inspect their personal fall arrest systems prior to each use for wear, damage, and other deterioration. If any components of the personal fall arrest system are found defective, they must be removed from service immediately. When inspecting a body harness, closely examine all nylon webbing for burns, marks, tears, and wear points. Ensure there's no torn, frayed broken fibers, pulled stitches, or frayed edges anywhere on the harness. Examine D-rings to ensure that there are no pits, deterioration, cracks, or excessive wear. Ensure buckles are not deformed, cracked, and that they operate correctly. Ensure all grommets are secured and not deformed. Ensure that the harness has no additional punch holes. Ensure all rivets are tight and not deformed. And check the tongue straps for excessive wear from repeated buckling. Additionally, an annual inspection of the harness should be completed by a competent person and should be documented. Harnesses should be stored hanging in an enclosed cabinet to protect from damage. Harnesses involved in a fall should be removed from service. When inspecting lanyards, check lanyard materials for burns, cuts, rips, abrasions, kinks, knots, broken stitches, and excessive wear. Ensure snap hooks are not distorted. Check carabiners for excessive wear, distortion, and lock operation. Ensure all locking mechanisms seat and lock properly. Once locked, the locking mechanism should prevent the hook from opening. Visually inspect shock absorbers for signs of damage. Ensure points where lanyards attached to snap hooks are free of defects. Lanyards should be inspected annually by a competent person and the inspection should be documented. Store lanyards in an enclosed cabinet to prevent any damage and remove any lanyards involved in a fall. When inspecting self-retracting lanyards, visually inspect it to ensure there's no damage to the body. Make sure all back nuts or rivets are tight. Ensure the entire length of the strap is free from cuts, abrasions, burns, kinks, and knots. Test the unit by pulling sharply on the lanyard to verify locking mechanisms are working properly. And return to manufacturer for annual inspection if required by the manufacturer's instructions. Horizontal lifelines shall be designed, installed, inspected, and used under the supervision of a qualified person as a part of a complete fall arrest system, which maintains a safety factor of at least 2. Lanyards and vertical lifelines shall have a minimum breaking strength of 5,000 pounds. When working with mobile elevated work platforms like man lifts or vehicle-mounted work platforms, body harnesses should be worn and the lanyard should be attached to the boom or basket. Engineered lifelines are fall protection systems that allow workers to move safely on elevated surfaces. Engineered lifeline systems must be designed and approved by an engineer or qualified person. Engineered lifeline systems must be engineered to have appropriate anchorages, strength of a line to hold the intended number of people, line strength to aid in the arrest of a fall, and durability to hold a fallen worker until rescued. A warning line system is a barrier erected on a flat or low-sloped roof to warn workers that they are approaching an unprotected roof side or edge. A warning line system includes a line and supporting stanchions. Where a warning line system is appropriate, the warning line system should guard the entire perimeter of the roof where work is being performed, be erected no less than 6 feet from the edge of the roof, use stationary posts made of wood, metal, or plastic, and have a wire or nylon rope and caution flags strung from post to post and be able to withstand 16 pounds of force. A safety monitoring system uses a competent person as a safety monitor who can recognize and warn workers of fall hazards. Safety monitoring systems are typically used as part of a fall protection plan during precast concrete work, leading edge work, and residential construction work when conventional fall protection is infeasible or would create a greater hazard. Additionally, when conducting roofing work on a flat or low-sloped roof that is 50 feet or less in width, a safety monitoring system must be used as a standalone fall protection technique. Fall protection requirements vary depending on the slope of the roof. For flat roofs greater than 50 feet wide with work performed 6 feet or greater from the edge, a warning line and safety monitor system can be used, and if the roof is flat and less than 50 feet wide, a competent person's safety monitor may be used. Only workers engaged in low-slope roofing work and workers performing specific job tasks covered by a fall protection plan are allowed in the area where workers are being protected by a safety monitoring system. The worker designated as the safety monitor may not perform other tasks that could take attention away from the monitoring function. A controlled access zone is a clearly marked, designated work area where certain work may take place without conventional fall protection systems. Controlled access zones are used to keep out workers other than those authorized to enter a work area. Situations where controlled access zones are used: in overhand bricklaying and related work, leading edge work, residential construction, and precast concrete erection. In overhand bricklaying and related work, controlled access zones can be used if workers are not reaching more than 10 inches below the walking or working level they are on. The control line shall extend along the entire length of the unprotected or leading edge and shall be approximately parallel to the unprotected or leading edge. The control line shall be connected on each side to a guardrail system or wall. Control lines must consist of ropes, wires, tapes or equivalent materials, and supporting stanchions. Be flagged or otherwise clearly marked at not more than 6-foot intervals with high visibility material. Be rigged and supported so the lowest point is not less than 39 inches from the walking surface. Highest point not more than 45 inches from walking working surfaces when overhead bricklaying operations are being performed. Have a minimum breaking strength of 200 pounds. Extend along the entire length of the unprotected or leading edge. Shall be approximately parallel to the unprotected or leading edge and be connected on each side to a guardrail system or wall. The following workplace hazards must be accounted for: hoist areas, holes, wall openings, ramps, runways, and walkways, excavations, dangerous equipment, and overhand bricklaying. Each worker in a hoist area must be protected from falling 6 feet or more by a guardrail system or a personal fall arrest system. There may be times when the guardrail systems must be removed in whole or part to facilitate hoisting operations. At such times, a personal fall arrest system must be used to protect the worker from falling through the unprotected opening. Each worker on a walking or working surface must be protected from tripping in or falling into a skylight hole. Each worker on a walking or working surface must be protected from falling through holes by using a cover. Each worker at the edge of an excavation of 6 feet or more must be protected from falling by guardrail systems, fences, or barricades when the excavation cannot be readily seen because of plant growth or other visual obstructions. Each worker at the edge of a well, pit, shaft, and similar excavations 6 feet deep or more must be protected from falling by guardrail systems, fences, barricades, or covers. When working 6 feet or more above dangerous equipment, each worker must be protected by guardrail systems, safety net systems, or personal fall arrest systems. When working less than 6 feet above dangerous equipment, each worker must be protected from falling into or onto the dangerous equipment by guardrail system or equipment guards. Each worker working on, at, or above, or near wall openings must be protected with the guardrail systems, a safety net system, or personal fall arrest systems, where the outside bottom edge of the wall opening is 6 feet or more above the lower levels, and the inside bottom edge of the wall opening is less than 39 inches above the walking or working surface. Employers must provide a fall protection training program to workers who might be exposed to fall hazards. Training must include how to recognize fall hazards and how to minimize them. The employer must ensure that each worker has been trained as necessary by a competent person. Employers must provide initial training prior to exposing workers to hazards. In addition, employers must provide retraining as needed. Suggested training topics include overview of related OSHA regulations, nature of fall hazards in the workplace, correct procedures for assembling, maintaining, disassembling, and inspecting fall protection, use and operation of guardrails, personal fall arrest systems, safety nets, warning lines, and safety monitoring systems, as well as other protection used. Role of each employee in safety monitoring systems. Limitations on the use of mechanical equipment during roof work on low-sloped roofs. Correct procedures for handling and storing materials and erection of overhead protection. The roles of employees in fall protection plans, including rescue of a person who has fallen. And understanding and following all components of the fall protection program. When an employer has a reason to believe that a worker does not recognize existing fall hazards, the employer is required to provide retraining for that worker. For example, workers must be retrained when changes in the workplace render previous training obsolete, fall protection equipment or systems have changed, and when knowledge or use of fall protection systems indicate that they have not adequately understood or retained previous training. Employers must maintain written certification training records for affected employees. Records must contain the following: topic of training provided, name or other identity of employee trained, dates of training, name of the instructor who provided the training. Fall protection devices are crucial in keeping workers protected while working at heights. In this course, we've covered introduction, fall protection systems, the ABCs of fall protection, types of fall protection, inspection of fall protection systems, special situations, controlled access zones, other hazards requiring fall protection, and company responsibilities. Thanks for choosing JJ Safety, and thanks for watching.